Okay, so our first question is a probability question. We're being asked to circle the Okay, so our first question wants us to circle the word that best describes the likelihood that the spinner will land on green. Well, there is only one green out of 6 sections, so that would be unlikely. We've got to mark with a cross that it will land on blue. Now, if we take a look, we have got half of the spinner blue, so we would mark that at a half. And then the probability of it landing on yellow. There aren't any that are yellow. Ignore my shading. There aren't any that are yellow, so that would be 0. Okay, so we need to draw a bar on the bar chart to show that Cairo has a population of 12 million. Two cities are equal, write that down. Well, we can see that that's Bogota and Lima. C is to write down the population of Jakarta, which is, no, that's not true. C is to write down the name of the city with a population of 15 million, and that is Manila. And then work out the difference in population between Jakarta and Phoenix. So Jakarta is 40 and Phoenix is 3. So 14 take 3 is 9. In Manila, there are 19 badminton clubs and 60 football clubs. And we've got to do the ratio in its simplest form. It says badminton to football. So we do the badminton first and then the football. If I divide through by 10, I'll get 9 to 6. And then I'm going to divide through by 3 to simplify it all the way to 3 to 2. Okay, we've got to write down an odd number. Now, there is a choice of odd numbers. So 3, or you could have written 19, 51, or 81. A multiple of 12, you could have chosen 24 or 60. A square number is 16 or 81. And the prime number options were 3 or 19. Okay, we need to simplify the expression. Now, we don't show the time sign and we do any number work that we can. So 6 times 2 is 12, and then squash everything together. Here we are adding and subtracting from groups. So I've got 5 M's. This says take 2 M's. So I've got 3 M left. And then I've got 7 K's. This says add a K. So I've got a positive 8K. We need to work out the value of Y. So we're going to hop across and take the 3 off the 14 to give 5Y equals 11. And then we divide through by the 5. And you can actually leave it there. You have Y on its own, and it's equaling 11 over 5. If you want to take it further, then you could go on and express it as 2 and 1/5. Okay, so one of the fractions is equivalent to 4/5. Now, the best way to do this if you're not confident with your fractions is to just multiply this fraction up. So if I was to double it, it would give me 8 out of 10, and that isn't an option. If I was to times everything by 3, that's top and bottom, I would end up with 12 over 15, which again is not an option. I'll times through by 4, which will give me 16 over 20. 16 over 20 is there, so that would be my answer. Again, being asked to shade 4/5 of the shape. So 4 out of every 5 squares. So a row has 5 squares. So we're going to do 4 out of every 5. Now we're being asked to write it as a percentage. To change a fraction to a percentage, we just times by 100. Now there's divide by the bottom, times by the top. Best way to do this. So 100 divided by 5 is 20, and 20 times 4 is 80. Now this one we've got to be careful. 4/5 of a number is 48. So that means that 4/5 is equal to 48. Now, the best way to do this is to use the bar modeling. So we've got our bar that's split into 5. They're telling us that 4 out of the 5 is equal to 48. So 1 square means we're going to divide the 48 by 4 to get 12. So all 5 would be 12 times 5, which is 60. Okay, a pentagon has 5 sides. The size of each angle in an equilateral triangle is 60 degrees. We just divide the 180 by 3. Everything is equal. And there are 1,000 meters in a kilometer. Okay, the mode is the most common, so that is 4. 4 is coming up more than any other. The range is the biggest, take the smallest. So the range is 6. To find the median, we need to put these in order. So we'll do that first. And then we cross off one from the beginning, one from the end, and we keep doing that until we get to the middle, which is 5. So this is a very wordy question. So we've got Clark working in a shoe shop, and on Tuesday morning he sold some shoes, and the mean of the pairs of shoes was 34. So the mean is equal to 34. So a lot of words just to give us that piece of information. On Tuesday afternoon, he sold only 2 pairs of shoes, and the prices were 31 and 49. And we need to work out if the mean on Tuesday was more or less. So we're going to add, which gives us 80. And then you divide by 2, because that's how many are there, which is equal to 40. I'm just going to pause. I'm not sure I'm doing this one right. Okay, so we've got a very wordy question here with Clark. On Tuesday morning, he sold some pairs of shoes and the mean price was 34. So all those words to tell us that the mean is 34 on Tuesday morning. On Tuesday afternoon, he sold only two pairs of shoes and we've been given the prices. So we can work out the mean for the afternoon. The mean is going to be 31 and 49, which is 80. Divide by how many are there, which is 2, and we've got a mean of 40. Is the mean of all the pairs, so everything sold on Tuesday, more or less than 34? So the answer is going to be more because we've worked here that the mean for the afternoon is 40, which is substantially greater and will then lift the whole mean for the day up. You could also argue that 31 is only 3 less than the 34, and the 49 is 15 more, which is substantially more, and again, going to create a greater mean for the entire day. Okay, we're going to write this as an ordinary number. So we've got our 5.7. We're being told it's a power of 6. So we're going to make a number that is bigger by moving 6 places. So 1 around the 7, 2, 3, 4, 5, 6. All my little buckets are going to get zeros. So that was 5 zeros. So 5, 7, 1, 2, 3, 4, 5 is my ordinary number. Putting into standard form, we're going to do the opposite. The decimal point is going to move 1, 2, 3 places to give me 4 times 10. It was a small number, so I must remember it's minus 3 and not positive 3. Okay, we've got a probability question. Very wordy again. Probability generally is, to be fair. We're being told that the game, the score is found by multiplying. So the spinner and the dice are being multiplied and the results are being gathered into this table. So the first thing that they want us to do is to complete the table. So it's really just a times table grid. Part B, we want to work out the probability that his score is greater than 10. Now, be really careful here. Greater than 10 means you do not include 10. That's not greater. So we've got 1, 2, 3, 4 that are greater than 10. So for part B, we have got 4 out of a total of 18. Now for part C, we've got Adam and Carmen playing the game. Adam gets a prize if his score is 5 or less. Carmen, if it's a multiple of 6. And Carmen says the game's unfair because Adam is more likely to get a prize. So we've got to work out if that's true or not. So Adam is a score of 5 or less. So that's how many Adam can get, which is a total of 8. He's got 8 chances to win. Carmen's a multiple of 6. So 3, 6. So Carmen has 6 chances. So yes, it is unfair. Okay, there's a couple of ways that you could do this, and I will show you probably the easier way for this question, and then I'll just display an alternative solution and just talk a little bit about that. So we want the highest common factor, so we're really looking at factors. So the first thing we're going to do is look at the factors of the lower number. So we're looking for pairs of numbers that multiply to make the 40, and we just work our way around. Is it in the threes? No. Is it in the fours? Yes, it's 4 times 10. Is it in the fives? Yes, 5 times 8. Is it in the six? No. 7? No. 8? Yes, and we've already got the 8, so we know that we found them all. That's a really nice way of making sure you get all of your factors. Now, with the 64, because we're looking for a highest common factor, we really just want to test if these numbers are in the 64 rather than find absolutely every single one of them. Well, obviously the 1 is, and the 2 is. We might need to stop and think about it, but the 4 is, 5 isn't, 6, obviously 7, don't need to think about it. 8 is, and then 10 isn't, 20 isn't in 64, and 40 isn't. 8 is the highest common factor. Now, I am going to show you the alternative method and then explain why one is better than the other depending on the question. Okay, so what I've done is I've done the prime factor method. So you find your prime factors, then you populate your Venn, and the highest common factor is the middle section. And we would finish it off by doing 2 times 2 times 2 is 8, getting the same result, of course. Now, if you're asked to find a lowest common multiple or a highest common factor fairly early in the paper, this is probably going to be quicker and a bit more efficient. If you see that question near the end, you'll probably find this method is going to help you way more. It doesn't matter which method you use if it helps you get to the results. But as I say, questions that are towards the back of a paper would normally work better with this second method. All right, it does work with bigger numbers and it works with different style of questions as well. So this is a good one to be aware of and know. Okay, we've got a number pattern and we need to draw the fourth one. So there we go. Now, one way to do this is to possibly use your tracing paper if you find yourself just getting in a muddle with these types, and some people really do, and it's easy to get ourselves in a pickle. So if you were to use your tracing paper, then turn it over and just trace it onto the page, then all you've got to do is just add on that last little bit. So as a tip, if you are one of those students that just really don't like these questions. So how many sticks are needed for pattern number 7? What we want to do is go back to the patterns and just add up how many sticks are in the first one. So you add your sticks and you will work out that there are 7. So in pattern number 1, there are 7 sticks. Do the same with pattern number 2, and you'll work out there are 12. And in 3, you'll work out there are 17. Hopefully, you can now start to see a pattern, and that is that they are going up in 5s. We want to find the 7th, so we will just keep adding 5 until we get there. So the answer is 37. Now we've got to work out the pattern that uses exactly 62 sticks. Now, there are a couple of ways of doing this, but honestly, if you think about what we've just done in the last part, we've worked out that pattern number 7 used 37. Now, that was growing fairly quickly. 62 isn't too far away, so it probably makes sense to just keep going. So the next one would have been 42, then 47, 52, 57, and then 62. So we've got our match of sticks. That was 8, 9, 10, 11, 12. So the answer is 12. Now, Pedro's saying that there will be a pattern in the sequence with exactly 123 sticks, and we've got to decide if he's right or not. Well, let's take a good look at what he says, and then take a look at what we've actually got happening in our sequence. Ends in 7, ends in 2, ends in 7, ends in 2. This pattern has continued throughout. Ending in a 3 is not going to be in our pattern. So that's our reason for saying no. Okay, when we substitute, we want to show what we're doing. We're going to be doing 2 times G plus 3 times RH. So 2 times 7, which is 14, and 3 times minus 4. 3 fours are 12. We've got 1 negative, so it's going to be minus 12. We've not technically used this plus sign yet. Now, a plus and a minus, when they're together like that, become a minus. And 14 take 12 is 2. When you have a divide question, you take away the powers. So this would give us e to the 4. A power to a power means you multiply. So this would be y to the 16. Various methods. Crab's claw is one I use often, but I also use this, especially if we're not best friends with algebra. This makes it really easy. I'm going to be using it like a times table grid. So x times x is x squared. X times positive 9 is positive 9x. And I do encourage you to leave those signs in. It's going to help you see the next step. Minus 2 times x is minus 2x. And then minus 2 times 9 is minus 18. And then we nugget that through. We've got 1x squared. In the middle, we've got 9x take away 2x, which is a positive 7x. And then we've got our minus 18. Now, one of the biggest areas that I see go wrong is this bit here. A lot of students will read this as minus 2 plus 9. And of course, we are multiplying in. And we just forget that because we see those signs and we just want to do what we see. So just be careful there. Now, this one is really tricky because we've got a lot going on and we've got powers that are greater than just squared. So that has an impact here. First thing we're going to do is think about our numbers 16 and 20 and work out which times table goes into that. Now, the biggest times table is 4, and we want to use the biggest. Then we're going to look at C. The smaller out of the 2 powers is the one that we will use. So we've got C to the 4 or just C. C is smaller, so we will use that. Then we've got P to the 2 and P to the 3. P to the 2 is smaller, so we use that, but don't make it any smaller. And then we put our bracket in. 4 times something makes 16, so that's 4. I then want to make C to the power of 4. I've got 1 here, so I just need C3 on the inside. I then want P squared. P squared is already on the outside, so I don't have to do anything here. So to make the 20, I need a 5. I want a single C, it's already on the outside, and I want P cubed. P squared is already there, so just another P to get my P cubed. Not an easy question, that one. Okay, the line A to C is a diameter. The name of line A to B is a chord. And then we need to draw a sector. Now, a sector is like a slice of pie. So this would be one that I could colour in. I could colour in the semicircle as well. Just whilst we're here, I'm just going to tell you this one. Just while we're here, I'm going to tell you this one is our segment. All right. Okay, so we're being asked to rotate the triangle 180 degrees, about 7, 6. So the first thing we want to do is mark on our 7, 6. We would then grab our tracing paper and place it over the shape and our cross. And then my top tip here is to draw on from your stabbing point, just a little line, so that when you've stabbed with your pencil, so I've got my little highlighter, but don't know how easy you can see that, but that's where you would stab with your pencil. And then you would rotate, twist through, and use the blue marker to get it to 180, get it pointing down. That way you know you've got it in exactly the right position. The tracing paper will show you where to draw your new shape. And that is where it ends up. So hopefully that went well. We're being asked to describe the single transformation. Well, I can see it's been flipped, which means it's a reflection. Now, it's going to be reflected in a vertical line, slap bang in the middle. We've got 8 squares between these, so I'm going to count in 4. 1, 2, 3, 4, and my line is here. Now I've got to name that line. It's a line that crosses the x-axis at -1. So it's a reflection in the line x equals -1. Okay, we've got to complete the table of values. We've got quite a big rule that we're going to have to work with. The y coordinate is found by doing x squared minus 3x minus 1. So first thing to do here would be to just write it out. I like to show the time sign. Just write that rule out so you can see clearly what you're doing. The first one we're going to work out is the 3 because it's positive. I know I've got blanks further, at the beginning of the table, but they're negative numbers, and I would sooner work with my positives whilst I'm getting into the swing of the maths. So if I put 3 where my x's are, I end up with this. Now 3 squared is 9. 3 times 3 is 9. 9 take 9 is 0. Take away another 1 is minus 1. Now I'm just going to repeat the whole thing by putting a 1 in where the x is. So I've got 1 squared minus 3 times 1 minus 1. Now 1 times 1 is 1. 3 times 1 is 3. So I've ended up with 1 minus 3, which is minus 2, minus another 1 is minus 3. Now look what's happened. We've got to repeat. That's fine. We would expect to maybe see that. If you can start to spot a pattern, you might be able to save yourself some time. So here, I can see this minus 3, minus 3. Either side of that, I can see a minus 1 and a minus 1. So it stands to reason that this would be 3. And I will just show that. If this was split here, I've got minus 3, minus 3, minus 1, minus 1. They told me it was 3. So the next number is 3. Now that's great. Saved me a little bit of time, but I still have to put my minus 2 in. So I've got minus 2 squared. Take 3 times minus 2. Take 1. Now minus 2 times minus 2 will be positive 4. Minus 3 times minus 2 would be positive 6. And then I've got that minus 1. So that's going to give me 9. We are then going to plot the coordinates. So we've got 4, 3. We've got 3 minus 1. And we're just going to keep plotting, and then we're going to draw our curve. And your graph should look like this. So you want to make sure that you do a nice curve. If you are slightly off, they're not going to, like take a mark off you or anything. But what's really important is there are no straight edges. Here, it's very tempting to just go straight across and then go back up. You want to just dip down slightly, okay? This here was our turning point. So you can see the symmetry, and this is why those numbers were repeating themselves. So hopefully you can see how that table and that graph go together. Okay, let's code out these sentences. We've got red and blue, which is 5 to 3. We've got blue to green, which is 1 to 2. Now, we can't work on the problem they've given us until we've got a ratio that works together. And at the moment, they're not working together because they've got different blues. So what I'm going to do is multiply this through by 3 to write an equivalent ratio, which would be 3 to 6. My blues are now matching, which means I can combine them and make them all work together. They're telling us there are 48 green, so I'm going to put that in the green column, and then I'm going to work out what I multiply 6 by to get to 48, which is 8. So how many red? It'll be multiplied by 8, and 5 times 8 is 40. Okay, we're dividing fractions. Now, when you have a show that, what's very nice is they're giving you the answer basically. So we're just doing our method and showing that it's going to give us this result. First thing we need to do is get them into top heavy. So 3 times 4 is 12. Add on the 2 and you've got 14 over 3. And then 9 times 1 is 9 plus that 1 is 10 and you've got 10 over 9. Now it's keep, change, flip. So we're going to keep the 14 over 3, change to times, and then we flip this over. Now you can either multiply across as it is and then cancel down, or you could do a little bit of cancelling before you multiply across. Now, not many people do this, but it's a great little technique. I am going to divide my 9 and my 3. So I can cross divide a numerator with a denominator if they're in the same times table. They're both in 3s. So I'm going to divide by 3. And I'm going to create a 1 here and obviously a 3 here. I'm going to tidy it up so we can see what we've got now. We've got 14 over 1 times 3 over 10. I've made them a little bit smaller, which makes them a little bit more manageable. So I could just now multiply across and cancel from there. However, just to demonstrate the technique again, I can see that the 14 and 10 are in the 2 times table. So if I divide by 2, I would create 7 over 1 times 3 over 5. Now I've got really small numbers to work with. 7 threes are 21 over 5. I've got that denominator of 5 already, which is fabulous. 5s into 21 go 4, and you've got your 1 left over. Okay, so this is a pretty big question. Becky's going to throw the dice 200 times, and we've got to work out an estimate of the number of times it's going to land on an even number. So what we're going to be doing is the probability of an even number multiplied by 200. If we look at our even numbers, we've got 0.18, but then we've got 3x and an x. So I'm not going to know the probability until I've worked out x. So I've got a question to answer, but in that is a problem to work on. So let's look at our x's. We've got 2 here, 2, 3, and another one here. So we've got a total of 8 x's. Make a note of that. They equal a value that we are yet to work out. We've been told that 2 and 5 have these probabilities. And if we add those together, we get a total of 0.44. That means that the rest of them will add up to 1 minus 0.44. So when we've worked that out, we get 0.56. So my 8 x's are equal to 0.56. If I divide through by my 8, 8s into 56 is 7. I've got x equals 0.07. And if you're not sure about how that decimal would work and how many zeros you might get, you just do it in your bus stop and it will work perfectly. So let's go back over to our even. We've got 3 x's here and an x here. So we've got a total of 4 x's. So we want to work out what our 4 x's are. So we're going to be timesing through by 0.07. So we're going to be timesing through by 4. to give us 0.28. Now, equally, you could have spotted that 8x is 0.56. If I just half that, I will get my 4x. So there are ways to do this, not just the way that you're seeing from me. So the probability of even is 0.18 for the 2. For 4 and 6, it's 0.28. When we add those together, we get 0.46. So 0.46 times 200. Probability of even times 200. Now, because it's non-calculator, I'm actually going to split this into 2 and 100. 2 times 100 makes 200. So I'm going to take my 0.46, I'm going to double it. That's going to give me 0.92. And then I'm going to times it through by 100, which gives me my final answer of 92. There's a lot happening in that question. If you got that right, really, really well done. And our last question, which I'm going to be honest, is another pretty tricky one. We're being told that A is equal to 2n times 3 times 5m. And we've got to write 8a, so 8 times a, as a power of its prime factors. So what we really want to do is think about our 8 in prime factors, which is 2 cubed. So 2 cubed is going to get multiplied into our 2n times 3 times 5 to the m. Now, when you have got the same base number, you can use your power rule. And when it's a times question, you add. So what you end up here with is 2n plus 3 times 3 times 5 to the m. Another really quite big question. And that's it, we're done. So hopefully that's been a useful paper to help with your revision. We are doing our best to get these up as quickly as we can. Full-time teacher here, so really, really busy, but doing it, like I say, as quickly as I can. And hopefully you will subscribe and like if you're finding them useful, and we can get these papers out to as many people as possible.